Okay, class, today we will look at Python basics to prepare you for machine learning programming. In this module, we'll look at part one, we'll look at input, output, define variables, different types, numbers, string, Boolean, and then we'll look at math operations, math functions, how to use help and import modules. Okay, let's go to Jupyter Notebook and we'll begin the first topic, how to use input and output in Python. So for input, we can use built-in function called input to input any message to a variable you assigned. For example, here, I use input and I will assign the input value to A. If we run this code, and there's a small window to show that input a message. Here I can input, let's see, hello world, and enter. And then you can look at A's value. Now A's value becomes hello world. So if you want to define input a number, what you should do? So because what you input by default, it will become a string. The string can be denoted by single quote or double quote. If you look at here, the hello world is enclosed by single quote. So if we want to input number, and we need another function, is called evaluation or eval, and then we use input. This time you can ask people input a number. You write, if I input a number, and we look at A will contain 34. So without any quote there means A now it's a number. So that's how we use input. The next one we look at how to use output. So the output function in MATLAB is print. So you can print a string here. A string again in Python is defined in either single quote or double quote. So print I'm a string, then will become, it will output I'm a string. So I can also define a variable. Let's see that I'm also a string, and then we can print this variable A. Can also print out I'm also string. Okay, you can print numbers. You see, I want to print 3 plus 4, and then the print function will do the addition first, and then print out the result. I can also print out multiple messages. See, I'm a number. Separated by comma. I'm a string. It will print both of them. Or you can print also a string and also a variable. So whatever in A will be printed out too. Another thing is about printers, we can use a format to insert a variable into a string. For example, if I defined A equals 20, so I can print like I am, as a curly bracket, to denote that where this variable will be print, I want to print I am a equals whatever number, it will be put inside with the curl parenthesis. And to show that what will be input there, after the string, use dot and then format. Inside the format, we put a there. And you will see that the a will be inserted into the string. It's very useful when you have something you don't know that what you want to print when you write the code, but later you want to use a variable that to denote the number, and then you can use this method. Okay, this is a input output, and the next one we want to look at is see how to define variable. Okay, so we'll define a variable, and first define variable, we need to look at the rules to define variable name. There are a few rules you can use. The first rule is you have to use. First rule is the name can only contain letters, numbers, and underscores. And the underscore is the symbol. So I can define variable like use letter or use combination of letter, number, or underscores. For example, I defined the variable is called, let's see, machine underscore and then number. I can print it out. Okay, and then rule number 2 is the first letter, the first character, the first character must be either letter or underscore. So number is not allowed for the first character. For example, if I define this as underscore and then machine, I print out, it still work because underscore is allowed for the first character. But if I use number, let's see, 2, and here I use 2, print 2, well, it doesn't work. So show you that this is invalid. Okay, number 3, so we defined for letters is case sensitive. So therefore, if I define machine 1, 2, 3, and then later, when I use it, I accidentally use uppercase A here. When I print, I will see that this variable is not defined. So you had to change it back to lowercase, and this time still work. Now after variable, and the third topic we'll discuss about the different types of data. Here we only introduce the basic ones. So first, we know that there are numbers. For numbers, there are integers and float. So we can define a variable as an integer, the whole number. So you can use type function to look at as type. So it's an integer number. int represents the integer. Or I can define it as a float number. So a equals for float, that means it's a decimal number, it's a decimal part. So define the a equals 1.2, and then we look at the type of a, it will become a float number. Another type of data commonly used is string. So for string, it's a text information. So you use either single quote or double quote to indicate that enclose the text, and it will become a string. So you can look at its type. It's a string. I can also use double quote. I look at the type, still do the same thing. Another type we want to use, we want to look at is, it's often used by the condition loops, the condition structure, that is Boolean type. Boolean type only have two values. It either is true or false. So notice that for true and false, the first letter is uppercase. So if you change it to lowercase, it doesn't work. So name false is not defined. Okay, and then we come to the fourth topic. Let's look at the basic operations, basic math operations, and math functions. And now we first define two variables. Let's y is 2, b is 1.2, and we can do some basic operations for plus, minus, division, a divided by b, which is a forward slash, and multiplication is a star, a times b. For exponentiation, for example, let's see that 4 to the power of 2, we use double star. Or a to the power, or b to the power of, let's see, 3. And it's often used in conditional structures, floor division, coming out. And the remainder, or modulus. So if you only want to get the whole number, for example, a equals 13, b equals 4, we want to only look at this whole number with double forward slash. A floor divided by b, we look at we'll get this whole number. If we want to get the remainder, we use a percentage, and we'll get the remainder. The remainder is 1. Okay, this is a 6 basic operations, and there's another 2 functions. It's built-in functions for math that you don't need to use as module. You don't need to call any library or module, and you can directly use as absolute value and round up. So if I look at the absolute value minus 2, I can directly use ABS. If I round a decimal number 3.4, I can directly use it. It's round, and then parenthesis input the value you want to round, you get 4. If you do other mathematical calculations, and then you need to call a module, it's called math. So you can, there are 2 ways to import math module. One way is you directly import it, import math, and then later use a math as a prerequisite, and then dot, and then the built-in function in math. For example, I want to calculate sine 1.2, and then I can use math.sign to use it. Another way to import math is to the from math import any function you want to use. See, I want to use sine, and then later I don't need the math dot anymore. I directly use sine 1.2, and then I can do the calculation. So for both methods, you can import the math module and use their math functions. The difference is for the first one, you need to use math dot as the prerequisite. For the second one, you don't need. Also, for the second one, is more efficient because you know what function will use. You just import the function you want to use. But if you want import math, it will import all the functions. Okay, and then we look at, because we want to test different kinds of built-in functions in math, so I will import math directly, and then we'll use them later. And then I want to test, let's see that sine, sine function, and cosine function. And also we can test the inverse cosine function. Let's see the inverse cosine functions. If we input this value into it, it will get our degree, so 1.2 in radian. Other function we often use, like a square root. Do square root of 9. We know the square root of 9 is 3, so we test it. We get 3. What else? Math function. Oh yes, exponential, the natural number exponentiation, which is a math exp exponentiation, e to the power, let's say 2. And the inverse is of it is log, so we can do the natural log. If we input this number, it will do the opposite, it will return 2. Let's see whether you could do it. So log, that's natural log. If you want to the 10 base log, you can use log 10. Say 100, we know that 100 log should be 2. Okay, so if you want to look at how many math functions you have, what you can do is use help function, help math, and it will show you that all the functions in the math. So help and show you all the function you have. Like we do a test, so we find the function is a factorial, so we can test this function. We know the factorial. Let's see, 3. We know 3 factorial should be 6. Oh, I forget to use math dot. That is 6. What else we can do a test? There's a log 10, log 2. Oh, permutation. Yeah, this is a probability function. We can test the permutation. Let's see, permutation. 3. Permutation 3 is also 6. So let's do a test. Yes, that's right. You can also do a power. Let's see, math. First, x is a base, so we can input 3, and the power 2, it should be 9. Oh, again, I forget to put the power function into it. This shortcut shift enter. Oh, power, POW. Okay, and then let's look at what we still need to learn for part 1. That's pretty much we have for part 1. And to wrap up this part, we have learned how to use input output, define variable, and the basic data type and math operations and math functions, and we learn how to use help and import modules.